Hello students, how are you? Hope you are doing well in your studies. Students, in last session we have studied what are exothermic and endothermic reactions. We have studied in exothermic reactions energy releases and in endothermic reaction energy absorbed. In endothermic reaction energy is absorbs and in exothermic reaction energy releases. We have studied examples of exothermic and endothermic reactions in previous lesson. Let's discuss the phenomena of energy changes. Let's explain energy changes. Making and breaking bonds. Students, in a chemical reaction, bonds must first be broken, then new bonds form. Whenever any reaction occurs, initially it needs to break the bond, then new bonds form. Breaking bonds takes in energy. When bonds break, energy absorbed. Breaking bonds means energy absorbed. Energy is absorbed. Energy is absorbed during bond breaking process and energy released when new bonds form. Energy released when new bonds form. So making bonds, energy released. Energy released. What we have studied? During the new bond formation, energy released, and when bonds are breaking, energy is absorbed. So breaking bonds takes in energy, making bonds releases energy. Breaking bond takes in means energy absorbs. Energy is absorbed by the system. Energy absorbs, and making bonds, energy releases. Making bonds means when new bonds form. Let's discuss the example of an exothermic reaction. See, when hydrogen reacts with chlorine in sunshine, it forms hydrogen chloride. When hydrogen reacts with chlorine, the product is hydrogen chloride. This reaction occurs in sunlight. It means in this process, energy is absorbed by the system. Right? What happens? See, hydrogen and hydrogen. This is hydrogen molecule. It reacts with chlorine molecules and the formation of hydrochloric acid. Right? So what happens here? The bond between hydrogen and hydrogen chlorine breaks. Hydrogen and hydrogen, the bond between hydrogen and hydrogen breaks, and the bond between chlorine and chlorine breaks. And the new bond forms between hydrogen and chlorine. So it will be like this: hydrogen, hydrogen, chlorine, chlorine, and the new bond form between hydrogen and chlorine, hydrogen and chlorine. Right? So when we balance it, it would be 2HCl. The new bond forms between HCl. Right? So here, when the bond breaks, energy absorbs. And when new bonds form, energy releases. Look here, this is chlorine molecule and this is hydrogen molecule. There is a bond between chlorine and chlorine molecule and the bond between hydrogen and hydrogen molecule, single bond. To break the bond between chlorine and chlorine, energy is absorbed. Energy absorbed. Right? Similarly, to break the bond between hydrogen and hydrogen, energy absorbed. So what we are observing? Old bonds break, new bonds form. And here the new bonds are formed between hydrogen and chlorine. New bonds are formed between hydrogen and chlorine. So when new bonds are formed, energy released. Energy released. So it means energy are absorbed when bonds break. When bonds are breaking, energy release. And when new bonds are forming, energy released. I'm repeating, when bonds are breaking, energy absorbed, and when new bonds are forming, energy released. Right? What I said, when bonds are breaking, energy absorbed, and when new bonds are when new bonds are forming, energy released. Right? Look here, first the bonds in the hydrogen and chlorine molecules must be broken. So energy must be taken in for this, right? And here, new bonds form between hydrogen and chlorine atoms, giving molecules of hydrogen chloride. And this step releases energy. But what we are observing, the energy taken in step 1. Step 1 means during bond breaking process. So energy is less than the energy given out in step 2. Here, the energy absorbed is less. Energy absorbed is less. Means during bond breaking process, the energy absorbed is less in comparison to the bond forming process. When new bonds are forming, energy released. But this energy is more. Energy released is more and energy absorbed is low. Energy absorbed is less. Energy absorbed is less and energy released is more. So new bonds form between hydrogen and chlorine atoms, giving molecules of hydrogen chloride. This step releases energy. But the energy taken in step 1 is less than the energy given out in step 2. So this reaction gives out energy. Overall, it is exothermic. Why do I say that this reaction is exothermic? Because energy released is more than the energy absorbed. Reaction is exothermic. Reaction is exothermic because energy released energy released is more than the absorbed energy absorbed, right? It means this reaction is exothermic. So it means we have concluded that if the energy taken into break bonds is less than the energy released in making bonds, the reaction is exothermic. What I said, if the energy taken into break bonds is less than the energy released in making bonds, the reaction is exothermic. See, here hydrogen gas is passed in chlorine and the formation of hydrogen chloride is here. So here this reaction is exothermic. This reaction is exothermic because energy released is more than the energy absorbed, right? Let's see other example, and this example is for endothermic reaction. Endo means energy absorbed. Energy absorbed. Energy absorbed in the reaction. If we heat ammonia strongly, it breaks down to nitrogen and hydrogen. It gives nitrogen and hydrogen, right? Let's balance it. 2NH3, 3H2, right? And 2 plus 3H2. Now it is balanced. Okay. Let's see whether it is exothermic or endothermic. To check this, just draw the structural formula of ammonia molecule NH3, right? Here two molecules of ammonia. Okay. It gives nitrogen, one nitrogen molecule. The bond between nitrogen and nitrogen is double bond and 3 hydrogen molecule. Okay. This is this explanation is to make you understand only, right? See, what happens? Energy absorbed. Look here. This is ammonia, one ammonia molecule, and this is other ammonia molecule. To break the bond between nitrogen and hydrogen, energy absorbed. Energy absorbed, right? Between energy absorbed to break the bond between nitrogen and hydrogen. Here, here, and here. Similarly here. But here we can see new bonds are formed between hydrogen and hydrogen and nitrogen and nitrogen. So here in this case, energy released. Energy released. Now the question is, how do we know whether this reaction is exo or endothermic? To check this, we calculate whether the energy absorbed is more or energy released is more. If the energy released is more, then the reaction is exothermic, and if energy absorbed is more, then the reaction is endothermic. So here as we can see that the bonds in ammonia must be broken, energy must be taken in for this, right? For this, we need to heat it. And here the hydrogen atoms bond together. Similarly, nitrogen atoms also. It releases energy. But here, the energy taken in for step 1 is greater than the energy given out in step 2. It means the energy absorbed is higher, energy absorbed is more, energy absorbed is more than energy absorbed is more than the energy released. It means this reaction is endothermic, right? What I said here, energy absorbed is more than the energy released. It means the reaction is endothermic. Because the energy absorbed during the bond uh, during the bond splitting, during the bond breaking, right, is less than the energy released during the bond formation. So this reaction is endothermic. Energy absorbed is more than the energy released. That's why this reaction is endothermic. So what I said, if the energy taken in or absorbed to break bonds is greater than the energy released in making bonds, the reaction is endothermic. If the energy absorbed, if the energy taken in to break bonds is greater than the energy released in making bonds, the reaction is endothermic. Let's see the bond energies. The energy needed to make or break bonds is called the bond energy. This is the list for bond energies of some of the molecule. Hydrogen, the bond energy between hydrogen and hydrogen atom, 436 kilojoule per mole. Chlorine and chlorine, 242 kilojoule per mole. Similarly, the bond energy between hydrogen and chlorine is 431 kilojoule. It means, what does it mean? It means if we want to break the bond between hydrogen and chlorine, we need to give 431 kilojoule mole of energy. If we want to break the bond between chlorine and chlorine, we should give 242 kilojoule mole of energy. Similarly, if we want to break the bond between hydrogen and hydrogen atom in hydrogen molecule, bond between hydrogen and hydrogen atom, but this is the bond between hydrogen molecule, right? We need to give 436 kilojoule mole energy, right? Similarly, for hmm, other molecules also, right? This is some of the bond energies. Similarly, if new bonds are formed between hydrogen and hydrogen atom, 436 kilojoule mole energy will release, right? Similarly, for chlorine and chlorine, 242 kilojoule mole energy will release. It means we can say 242 kilojoule must be supplied to break the bonds in a mole of chlorine molecules. Look here. For chlorine, 242 kilojoule mole and kilojoule per mole energy must be supplied to break the bonds in a mole of chlorine molecule and to give chlorine atoms. If these atoms join again to form molecules, 242 kilojoule of energy are given. So we can summarize that bond energy is the energy needed to break bonds or released when these bonds form. Means same energy we need to give to break the bonds, and when new bonds form, the same energy will release. It is given in kilojoule per. Calculating the energy changes in reaction. How to calculate the energy changes in reaction? So for this, we have a formula. Calculating energy changes. Calculating energy changes is equal to energy minus energy out. Energy changes is equal to energy in minus energy out. Look here, it is written here, energy changes. To calculate it, energy in minus energy. Let's see the example of exothermic reaction between hydrogen and chlorine. How to calculate this? Here the exothermic reaction between hydrogen and chlorine, H2 plus Cl2, it gives HCl. HCl, right? We can write it like this. Hydrogen, 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 single bond between hydrogen, right? Similarly, we can write it like this, 2HCl. Let's see the bond energy between hydrogen and chlorine and chlorine. Let's see the table. The bond energy of hydrogen and hydrogen is 436 kilojoule. 436 kilojoule. Similarly, the bond energy of chlorine and chlorine atom is 242 kilojoule. 242 kilojoule. Right? So it is 678 kilojoule. It means we need to give 678 kilojoule energy to break the bond between hydrogen and hydrogen. Right? It means, I'm just a minute. It means we need to give, excuse me, I'm correcting myself. We need to give 436 kilojoule of energy to break the bond between hydrogen and 242 kilojoule of energy to break the bond between chlorine and chlorine atom, right? And overall energy, total energy we need to give is 678 kilojoule to break the bond between hydrogen and chlorine and chlorine, right? This is energy in. Energy in means energy absorbed. This is absorbed energy. Let's see the energy released here, because here new bonds are forming. New bonds are forming here. It means energy released here. Let's see the bond energy of HCl. It is 431. Here 431 kilojoule of energy is released. But here 2 moles of HCl. So it means it would be 2 multiplied by 431. It is 862 kilojoule. It means 862 kilojoule of energy released. 862 kilojoule of energy released during the reaction. It is energy out. Energy out or energy released. Released energy. Let's calculate it. Inputting the formula. The formula is energy in minus energy out. Energy in is 678 and energy out is 862 kilojoule. It is, the answer would be negative minus 184 kilojoule, because the answer is in negative. It means it is exothermic reaction. Means energy released is more than the energy absorbed. This reaction is exothermic because energy released is more than the energy absorbed. Right? Look here, it is explained here. The exothermic reaction between hydrogen and chlorine, bond between hydrogen and hydrogen, chlorine and chlorine single bond gives 2 moles of HCl. Energy in to break each mole of bonds. 1 multiplied by hydrogen and hydrogen, and here it is 436 kilojoule, and energy to break the bond of chlorine and chlorine is 242 kilojoule. The overall energy absorbed is 678 kilojoule. And energy out from the 2 moles of bonds forming, right? And here, right, the formation of HCl here, 2 moles of HCl. So it would be 2 multiplied by 431. The energy out is 862 kilojoule. After putting the formula, energy in minus energy out, 678 kilojoule minus 862 kilojoule, the answer is minus 184 kilojoule. As the answer is negative answer, so it is exothermic reaction. Its energy level diagram should be like this. It is energy on y-axis and right. So energy, let's see, it is energy, right? So this is the energy of reactant. This is the energy of reactants, right? And this is the energy of products. We can see the energy of products is on the lower side. It is on the higher side. It is on the lower side, right? So this is the energy level diagram for exothermic reaction. To draw the energy level diagram for exothermic reaction, the product's energy will be less. The energy of product will be less. The energy of product will be less. See, here it is on the higher side, it is on the lower side. This is energy. Let's see the example of endothermic decomposition of ammonia. Let's calculate the energy. Let's calculate whether the reaction is exothermic or endothermic. See, decomposition of ammonia. It is 2NH3, right? 2 molecules, 2 moles of ammonia. NH3, it gives nitrogen molecule, 1 nitrogen molecule and 3 hydrogen molecule. Right? See, how many bonds are there between nitrogen and hydrogen? 1, 2, 3, because here these are 2 moles. So here 6 bonds, right? 6 bonds are between nitrogen and hydrogen, right? So energy in to break the 2 moles of bonds, 6 multiplied by nitrogen and hydrogen. I hope you understood. You have understood that here these are 2 moles, right? So we can see that nitrogen, hydrogen, right? Nitrogen and hydrogen, 2. So we can see here 6 bonds, 1, 2, 3, 4, 5, 6. So 6 into NH, and after putting the value of bond energy between nitrogen and hydrogen, see it is written here 391 kilojoule. 391 kilojoule. Right? The answer would be 2346 kilojoule. Similarly, we will calculate the energy out from the 4 moles of bonds forming. The energy, the bond energy to form the bond between nitrogen and nitrogen is, let's check here. See here, it is 946 kilojoule. 946 kilojoule. It is written here. Because here, and the bond energy between 3 hydrogen and hydrogen molecule, to break the bond between hydrogen and hydrogen atom, it is 436 kilojoule, because here are 3 molecules of hydrogen, so it would be 3 multiplied by 436. 3 multiplied by 436. See? So the answer is 2254 kilojoule. After putting in the formula energy in minus energy out, the answer would be plus 92 kilojoule. Because the answer is positive, it means the reaction is endothermic. It says that the energy absorbed is more than the energy released. Positive sign indicates that energy absorbed is more than the energy released. So this reaction is endothermic. Right? Okay. To draw the energy level diagram for this reaction, see, the energy of product will be higher, high energy of the product for endothermic reaction. And the reactant's energy is less. The energy of reactant is less, right? Reactant's energy is less and the product's energy is high because the reaction is endothermic, because the energy is absorbed during the reaction, right? So starting a reaction, bonds must be broken. We have understood that this needs energy. For some reaction, not much energy is needed. Just mix the reactants at room temperature. Some exothermic reactions need heat from a Bunsen burner just to start bonds breaking. Then the energy given out by the reaction breaks further bonds. But for endothermic reactions like the decomposition of calcium carbonate, you must continue heating until the reaction is complete. This is the one way to get those bonds breaking. It means to break the bonds, energy absorbed, right? Heating is required to break the bonds. I hope you have got your concepts clear.